Okay, let's jump right into this explainer. And honestly, we need to completely rethink everything we know about artificial intelligence. For the last couple of years, we've been absolutely obsessed with what AI can say. But right now, a massive shift is happening. We're moving away from the chat window and focusing entirely on what AI actually does. And more importantly, the literal physical footprint required to let it do those things.
So, I want to start by asking you to challenge your current perception of AI. Because, look, the real story right now isn't about some new chatbot model dropping this week or a tiny bump in a benchmark score. It's a much more fundamental question. Are we still just buying a software product, or are we financing and building something closer to the national highway system or the power grid?
There's a quote from some recent industry analysis that really hits the nail on the head here. AI is leaving the chat window and becoming an operational system. And when AI becomes an operational system, it totally transforms. It evolves into a complex, heavily capitalized, and regulated physical infrastructure. It basically stops being a neat trick on your screen and starts doing actual heavy lifting work in the background. When we lay out the differences between the old view of AI and this new reality, it's pretty stark. Old AI, that was pure software. You prompted a single model, it spat out some text, and that was the whole shebang. But new AI is physical infrastructure. It needs land, it needs mind-boggling amounts of power, complex routing, and persistent agents that just run for days on end. It takes massive financial orchestration, literally just to keep the lights on. And if you look at this timeline from August 2026, you can see just how incredibly fast this industry shifted. I mean, we went from a massive capability shock on August 6th, where everyone was suddenly focused on rogue AI agents escaping their valuation boundaries, straight into building external controls by the 13th. And by August 20th, we had landed on fully capitalized institutional operations. The speed of this transition was just wild. Section 1, the trillion-dollar infrastructure. Let's move over to the financial layer and actually see how this new grid is being built and funded. Because you really have to consider the immense scale we're talking about here. A reported $105 billion. That's the amount of credit support NVIDIA agreed to provide just to guarantee capacity for OpenAI. This isn't your standard software procurement budget, right? This is the kind of massive financing structure you normally only see when building international oil pipelines or national energy grids. Suppliers are stepping up with huge money to ensure the ecosystem keeps growing. And where exactly does that mountain of money go? Well, that financing supports a massive 8 IT gigawatt Ohio campus leased from SB Energy. 8 gigawatts dedicated entirely to computing equipment. To put that into perspective, that is a staggering amount of electricity, literally enough to power millions of homes. It proves that chip demand, electrical power, and physical construction are now rolled into one single financial structure. You can't just buy the chips anymore. You have to buy the power plant and the land they sit on. The big takeaway here is that AI infrastructure isn't just about buying servers anymore. You're financing national-scale physical assets. So if you're an executive, your capacity strategy now has to include counterparty risk, like what happens if your provider goes under? It includes energy exposure. What if electricity prices suddenly skyrocket? And you absolutely need ironclad exit rights because you are bound to a physical reality now. Section 2, routing, payments, and margins. Just like a physical power grid needs substations to direct electricity efficiently, the AI ecosystem needs a way to direct massive volumes of data requests. And that brings us to a really vital concept, model routing. Understanding this is absolutely crucial because no single AI model is perfect for everything anymore. A router acts kind of like a traffic cop. It decides in real time if a task needs the smartest, most expensive model, or if a cheaper, faster one can get the job done. And whoever controls this routing layer, they influence which model wins each request and ultimately who keeps the profit margin. Which perfectly explains this massive market move. Stripe's agreement to acquire OpenRouter. This deal brilliantly illustrates how routing, metering, and payments are totally converging. By acquiring a platform that spans over 400 models from 80-plus providers, with outside valuations reporting anywhere near $7.5 to over $8 billion, Stripe isn't just processing payments anymore. They're acquiring the economic governor for AI. They connect model selection right to token optimization and billing. The router is now a highly strategic choke point. Section 3, Rise of Persistent Agents. So what actually happens when this infrastructure stops just answering our questions and starts taking continuous, independent action? Well, we are seeing the rise of persistent agents. Take AWS Agent Core, for example. These are managed instances engineered to remain active for up to 14 days at a time. This isn't just typing a prompt and getting a quick response. This is an AI actor living on your network, holding state, retaining its memory, and continuously working on tasks for 2 solid weeks. Which brings up a critical question that literally every IT and security professional needs to be asking right now. What happens to your security when an AI agent runs for 14 days straight? Think about the blast radius of a long-lived AI operating on your network. When an agent is alive for that long, holding active credentials and pinging databases, your entire risk profile changes.
And we've already seen what happens when this goes wrong. Real-world vulnerabilities, like the co-snitch exploit, show us that attackers can actually manipulate the assistant itself. They can combine auto-run prompts with connected data, leading to memory poisoning and data exfiltration. Because the AI is doing actual work now, safety has to govern memory, external connectors, and containment. You absolutely must have identity controls and an immediate, reliable kill switch.
Section 4. Policy hits the physical world. Because the starkest reality check for this new AI grid isn't digital at all, it's entirely physical. The upcoming release of the book Designing AI Data Centers really drives this home. We are moving AI out of pure software abstractions and right into the physical world. We're talking about exascale data centers, factories capable of a quintillion calculations per second. You can't just deploy code anymore. You have to deal with massive cooling architectures, enormous water usage, and strict physical security perimeters. Because of this, our whole concept of AI policy is completely splitting in two. On one side, we have the digital policy we're used to, data privacy, model safety, watermarks. But on the physical side, that policy is rapidly taking over. Now we're debating water usage, land rights, and local grid upgrades. The most pressing policy question right now is simply who pays to upgrade the local power grid when the AI gets smarter and needs way more juice. And we are already seeing this play out in the real world. Pennsylvania's Executive Order 2026-05 is a perfect example. It specifically targets AI projects drawing over 25 megawatts. It removes any fast-track treatment and requires community consent, demands transparency, and enforces strict environmental and ratepayer protections. It proves that AI policy is now a hyper-local issue of water, electricity, and community approval. Simply put, you can't build the infrastructure if the local town votes no. Section 5. The Executive Playbook. So how do strategic planners and business leaders actually govern this massive paradigm shift? Well, this 90-day management agenda gives you actionable steps to move from just buying chatbots to managing a robust AI infrastructure stack. In the first 30 days, you need to map your dependencies and quantify your exposure limits. Days 31 to 60, you review contract controls and actively test your agent containment. And by day 90, you're defining public impact readiness and establishing clear board metrics. It's all about disciplined execution. Navigating all of this requires managing 5 core decisions: capacity, placement, concentration, authority, and exit. And listen, these cannot be delegated. Why? Because a low-cost model might require really expensive data movement. A highly secure private deployment might create dangerous vendor concentration. Every single choice directly changes the cost, risk, and feasibility of all the others. It's like a giant puzzle. You really have to look at the whole board. As we wrap up this explainer, I want to leave you with one final provocative question. Are you managing AI as a chatbot procurement or as a governed action system? Because if you keep treating AI as just another standard software purchase, you are going to miss the most fundamental technological shift of this decade. The winners won't just be the ones with the smartest models. They'll be the ones who govern and master the entire physical and financial system.